Welcome to The Explainer. Today, we're taking top-tier engineering research and turning it into a highly actionable playbook for developers and founders who are, frankly, just frustrated by skyrocketing AI API bills. If you are running generative AI models in production right now, you already know the sheer pain of watching your token usage just multiply day after day. Well, today, we're going to fix that. So let's just jump right in and anchor on one absolutely massive number: 80%. Through strategic optimization across your entire stack, you can actually slash your LLM token costs by up to 80%. And the best part? You can do this without sacrificing a single drop of output quality. This isn't about compromising what your app can do. It's entirely about engineering discipline. To get us there, here is the playbook for today. We'll be covering the token economics crisis, smarter chunking and prompting, the prompt compression breakthrough, mastering LLM context caching, smart routing and governance, and finally, the true cost equation. We'll follow the lifecycle of a single user request, systematically plugging the leaks in your budget.
All right, let's kick things off with Section 1, the token economics crisis.
Here is the harsh reality of why unoptimized applications bleed money. Output tokens cost 2 to 5 times more than input tokens. Let that sink in for a second. On a model like GPT-4 Turbo, you might pay 1 cent per 1,000 input tokens, but a whopping 3 cents for the exact same amount of output tokens. So what does this mean for you? It means controlling your output length using max tokens, stop sequences, and requesting incredibly concise formats has an outsized, immediate impact on your final bill. If you aren't strictly governing what the model sends back to you, you're just burning cash. Moving right along to Section 2, smarter chunking and prompting. You know, the easiest win in this entire playbook is literally right in front of us, preparing your data before it even hits the model. Think about a bad, overly conversational prompt that says, "Please read this document and carefully extract," compared to a highly optimized prompt that simply says, "Extract names, return JSON only." Eliminating all that redundant, polite filler and demanding structured formats like JSON immediately stops you from paying for useless words. I mean, you really don't need to say please to a language model, and you definitely don't need to pay for it to output verbose, conversational filler when a simple JSON object is what your app actually needs. Now, when you're handling larger documents for RAG systems, the old way of doing things was fixed-size chunking. That's basically slicing documents up into rigid 500-character blocks, completely destroying the context and forcing the LLM to guess what got cut off. It's like taking a meat cleaver to a book. Instead, we should be using semantic chunking. This calculates the semantic cosine distance between sentence embeddings. Basically, when it detects a major shift in meaning, like the top 15% of distance shifts, it creates a dynamic split. This ensures every single chunk contains one logically complete idea, which keeps our retrieved context highly relevant and super compact. Which brings us to Section 3, the prompt compression breakthrough. Even with great chunking, retrieved text contains a ton of noise. Enter prompt compression, driven by a really interesting concept called perplexity. Think of perplexity as a metric smaller language models use to measure how surprising a token is. By measuring this, they can evaluate your prompt, figure out which tokens are highly predictable, and filter out all that boilerplate code and redundant filler words, words like the or which is, before you ever send that data to the expensive generation model. You keep the core meaning, but you completely drop the token weight. A prime example of this in action is Microsoft's LLM Lingua. This tool leverages this exact perplexity metric to compress prompts by up to an astonishing 20 times. 20x! What makes this an absolute breakthrough is that it works directly on black box LLMs like GPT-4 or Claude, and it requires zero additional training on your part. It just aligns a small model to detect unimportant tokens, stripping them out, while miraculously retaining the large model's ability to reason and perform in-context learning. For massive context windows, this is a total game changer. Next up, Section 4, mastering LLM context caching. This is your highest ROI cost lever for long context workloads because you skip redundant work entirely. But to actually get cache hits, you have to follow the cache breakpoint pattern exactly. Caches hit on prefixes, so you need to stack it properly. Put everything stable, like your system prompt and tool definitions, at the absolute top. Put your slowly changing context next, and everything highly variable, like the current user message, at the very bottom. If you mess this up, say by dropping a variable timestamp into your system prompt at the top, you break the prefix, invalidate the entire cache, and completely wipe out your savings. And the financial incentives for getting this right are just staggering. Anthropic is offering a massive 90% discount on cached inputs if you use their explicit breakpoints. Meanwhile, OpenAI provides a totally hands-off, automatic 50% discount once your stable prefix crosses a 1,024 token threshold, and Azure mirrors that exact setup. If you are running agent loops or RAG pipelines with large, stable instructions, doing this alone cuts your input costs in half, or far better.
Okay, let's talk infrastructure in Section 5, Smart Routing and Governance.
Look, you absolutely do not need a massive, expensive frontier model for every single query. The model ladder strategy dictates that you route simple tasks, like classification and extraction, to your budget-tier small models. Use media models for general tasks, and you reserve those pricey frontier models strictly for complex reasoning. On top of that, setting up automatic fallbacks is crucial. If an API call fails, an automatic fallback stops your agents from entering endless retry loops that just pointlessly drain your budget on failed calls.
Now, for complex agentic workflows, things get even more resource-intensive. Imagine having 150 different tool definitions. Stuffing all of them into your prompt context on every single turn will literally bankrupt you. But by using a gateway feature like Code Mode, which actually gives the model a Python sandbox to dynamically load tool signatures on demand, you can reduce input tokens by up to 92.8%. It stops the model from having to reread a massive tool catalog every single time it makes a decision.
Finally, let's wrap this all up in Section 6, the true cost equation. So here's a bit of a plot twist for you. Is prompt compression always the right move? Actually, no, it's not a free win. Why? Because you are spending local computation time to save API generation time. You have to balance these engineering trade-offs and evaluate the break-even point to know if it's actually helping your specific architecture.
This perfectly highlights the compression break-even point. In scenario A, compressing 4,500 tokens for a high-latency downstream model like GPT-4o takes about 110 milliseconds locally, but it saves you a full minute of API generation time. Massive win, right? But look at scenario B. If you are using an ultra-fast streaming model like Haiku, running that same compression locally could take 350 milliseconds on a CPU, which actually slows your entire system down compared to just letting the fast model process the raw tokens. You've got to match your optimization strategy to your specific constraints.
So I want to leave you with this final thought to really challenge your architecture. Is your AI budget funding actual intelligence, or are you just paying for redundant filler tokens, poorly chunked text, and inefficient routing? It is time to apply this playbook. Filter out the noise through semantic chunking and compression. Enforce a strict model ladder. Optimize your cache breakpoints, and start paying only for the tokens that actually matter to your business. Thanks for joining me on The Explainer, and happy building.